Hi folks, this is question 4. First one, it gives us complex number, so it's a complex number over a complex number. Therefore, I'm going to multiply top and bottom by the conjugate of the bottom. Therefore, if we multiply out everything on top, it gives us 8 plus 10i plus 12i plus 15i squared. And the bottom gives us 16 plus 20i minus 20i and minus 25i squared. Therefore, on the top, the I squareds turn into minus 1s. So therefore, on top, we have 8 minus 15. That's minus 7. And plus 22i. And on the bottom, the 20i and minus 20i cancel. The I squared, again, changes to a minus 1. And that turned into a plus 25. So 26 plus 25. Sorry, 25 plus 16 is 41. And then we can split that up into minus 7 over 41 plus 22 over 41i. And that's the form that they wanted in. The second part, we have to use the expression cos theta plus I sine theta squared. Firstly, I'm just going to square out everything here. So cos theta times cos theta is cos squared theta. And cos theta times I sine theta is I cos theta sine theta. And then I sine theta times cos theta is plus I cos theta sine theta. And then I sine theta times I sine theta is plus I squared sine squared theta. Therefore, if I put the two things in the middle together, they're the same thing, so I just get two of them. So plus 2 I cos theta sine theta. And the I squared there again turns into a minus 1. Therefore, it's cos squared theta minus sine squared theta. Therefore, uh, that's what we're getting when we just expand it out. Now, I'm also going to write that expression, okay, this expression here, in a different way. So, cos theta plus I sine theta all to be squared. If I was to use the Moivre's theorem for that, that would just be where I put in the 2 in beside the angle. I'm basically multiplying the angles in it by 2. So that's just cos 2 theta plus I sine 2 theta. That's just using the Moivre's theorem. And that's where they want us to use the Moivre's theorem. So I'm going to put that into a red box as well. And then the two things in the red boxes are both that thing written in two different ways. So the two things in the red boxes there have to be the same thing. So if so cos uh, so cos of theta is I sine sorry cos squared theta plus sine squared theta plus 2i cos theta sine theta. So that's the first red box. That has to be equal to cos 2 theta plus I sine 2 theta. Then it's just about letting the real parts be, because the real parts have to be the same as each other. So that there is equal to that. That's the thing we have to solve then. Or that's the thing that we were asked, that we were asked to prove. And that's also cos squared theta plus sin squared theta is equal to cos 2 theta. And then part C. Now the last part, Z6 is equal to, really that's 0 minus 64i. Therefore Z is equal to 0 minus 64i all to the power of 1 over 6. So the first thing I'm going to do here is find out what it is in polar form. Therefore r is equal to root 0 squared plus minus 64 squared. And it will just be 64. And that's always how we get r. And so our polar form is r cos theta plus I sine theta. And then we need to get the angle as well. If we're to sketch out where that is, it would mean that you're going across to 0 and up to 64. Obviously, so it'll be up here. So that's where, oh, sorry, it's minus, so it should be down underneath. So it'll be down here, so that's 0 minus 64i, that's where it is on the Argand diagram. Our angle is always measured from here. We start here, so if I was to go around to there, if it was in degrees, that would be 270 degrees. If it's in radians, well, just from there to there is pi, and then that's another half pi. So that's 3/4 pi, 3 pi over 4. That will be my angle, 3 pi over 4 to get to there. Therefore, 0 minus 64i is equal to, it'll be 64, that's what we're putting in for r, cos of 3 pi over 4 plus I sine 3 pi over 4. And if we were to go around 360 degrees from there, we get back to the same point again. So therefore we have to do plus 2n pi, and that just means that we can keep going around rotation. So if you look back at our roots of these questions, that's what we have to do. So that's cos 3 pi over 4 plus 2n pi plus I sine 3 pi over 4 plus 2n pi. Actually, just as I'm seeing it, spotting a mistake. So the angle isn't 3 pi over 4, it's 3 pi over 2. Because from there to there is pi, and then we're going another half pi, so that's 3 halves, basically. So that was just a mistake. So we'll just change them all to just over 2. And we'll carry on. We need to raise the 64 to the power of 1 over 6 as well, actually, because we're doing, it's that to the power of 1 over 6. So we do that with the r as well, and that will just give us 2. So we get 2 cos 3 pi over 2 plus 2n pi plus I sine 3 pi over 2 plus 2n pi. Also, because we're using the Moivre's theorem in there, we're putting in the 1 over 6. We're multiplying the angle, which is that really, by 1 over 6. And that is the same as just putting it over 6. And the same here. Now I can tidy up the fraction a little bit here. That will be 2 cos of 3 pi over 12 plus just n pi over 3, because the 2 will cancel out, plus I sine of the same thing, 3 pi over 12 plus n pi over 3. And really, because it's 1 over 6, because it's the whole question started off with z6, so therefore there's 7 roots that we could get here that if we wanted, but they only want us to get 2. Therefore all we have to do is just sub in n equals 1, and then just sub in n equals 2. So if I put in n equals 1, or well, no, sorry, actually, I can just put in 0 and I can put in 1. So if I put in a 0 in for n, I would get 2 cos of, well, the whole second part is gone, so it's just 3 pi over 12, which is pi over 4. Plus I sine of pi over 4. And that's it, because the second part is just gone again when you put in a 0. My brackets are kind of everywhere here. So, and that's it. So you can just use calculator to see what pi over 4, cos pi over 4 is, and sine pi over 4 is. And in the end, you should get root 2 plus I root 2. And we're going to do the same for the other one. Then you just put in a 1 everywhere. So the second one, it would be 2 times 3 pi over 12 plus, well, n is 1, so therefore plus pi over 12 over 3. Should be a cos in there, plus I sine 3 pi over 12 plus pi over 3. And that's it. And if you use calculator to do the cos bit and then multiply it by 2 afterwards, because there's a 2 outside, and then do the same with the sine, it'll tell us what both things are. And it's a bit awkward in the end, so you get minus root 6 plus root 2 over 2 plus root 6 plus root 2 over 2 as well.